Okay. It's still preparation time, so we're very well in time. Is everything okay with the sound? It's time to start. We have the report of the team Team Gravity Z on problem number 4, colorful lines. The report is starting now. You have 8 minutes.
Well, hello everyone. My name is Andy, and I will be doing the report for problem number 4, colorful lines by Team Gravity's Cubed. First of all, the problem to be investigated stated that if a line is drawn on a rough surface with a piece of iron sulfide, the line has a different color than the mineral piece itself. We had to investigate this phenomenon and explore what other minerals were to show similar properties. First of all, for some introduction on iron sulfide. It has an ideal formula of VES, as you can see here as well. It is comprised of iron and sulfur. It has a crystal structure, as the image below shows as well, that belongs to the cubic system, which means that the crystals have a regular arrangement of atoms in the 3 dimensions. It is also a part of the family of minerals. It is metallic. We will explore that in a bit. Some brief introduction of minerals is that by definition they are homogeneous inorganic substances that occur naturally, usually in a crystalline form, as we saw of iron sulfide as well. Next slide, please. Now, let's look at the difference between metallic and non-metallic minerals. Metallic minerals are the minerals which contain one or more metallic elements, as we saw with iron sulfide as well, while non-metallic minerals do not contain any metal in the chemical composition. So as we can see here, metallic minerals are the ones who do contain a metallic luster. They are, let's say, shiny on the outside, but non-metallic minerals, because they do not contain any metallic elements in the composition, they do not have that luster. Now, iron sulfide belongs in the family of minerals called sulfides. Let's say the name of iron sulfide is pyrite, is this mineral here. And some other minerals in the family of sulfides are chalcopyrite, sphalerite, and galena, which you'll see why they are relevant later. And another category which we decided to investigate when it comes to this, and we will explore that a bit later, is a category of silicates, which you can see here. We will explore that in a bit. Now, it is very, very important to distinguish the differences between the surface color and the streak color of a mineral. This is because the surface color can be influenced by a variety of factors. For example, environmental factors, such as if it is evident to any oxidation, or any impurities that may be evident in the mineral can also change the surface color of the mineral. However, the streak color is used to better identify a mineral because it can show us the true color of the mineral. And this is because we are able to scrap through the outside layer and get to the inside layer of the mineral. So for example, 2 minerals that may have a different outside color, their same outside color, the streak color will differ because it's a different color. Now, iron sulfide minerals, as I mentioned before, they have a unique crystal structure. The iron atoms are surrounded by sulfur atoms in a 2-to-1 ratio, and it's a unique crystal structure, as well as the fact that they contain metals, that they give the mineral the metallic luster and the high reflexivity. However, when the mineral is powdered and when it is presented in a powdered form, the light can reflect differently than the particles in the powdered form than the particles of the mineral. And this is why the streak color of iron sulfide is different than the color of the mineral piece itself. However, next slide, please. When it comes to silicates, as I mentioned before, they are non-metallic minerals. They do not have a metallic luster. This is the main difference that they have with iron sulfide. They are composed of silicon and oxide. And when silicate minerals are scratched or powdered, their streak color remains similar than the color of their outside color because, again, they are non-metallic. They do not have that luster. And some examples are agate, jasper, and citrine, which we decided to look more into. Now, our hypothesis. According to our theory, our first hypothesis was that the iron sulfide, otherwise known as pyrite, will leave a different color than that of the mineral piece itself. Our second hypothesis was that minerals of the same form of occurrence as iron sulfide, so other minerals which I explained before as well in the family of sulfides, will leave a streak color of a different color than that of the outside piece, similar to pyrite. And our third hypothesis, according to our theory, was that minerals that fall under the category of silicates will leave a streak color that is similar to the mineral surface color. Now, moving on to our experimental procedure. What we did is that we took the pieces of the minerals and we stroked them in sandpaper 5 times. We took pictures of the samples. We used a color picker in order to pick 5 colors of each, 5 points of each of the 5 streaks, blend the colors together in order to get the color of the streak, and then we analyzed the colors. Next slide, please. Now, for our first experiment, our independent variable was the mineral. We used pyrite. Our dependent was the color of the streak, and our controlled were the type of the sandpaper, the kind of mineral, the roughness of the sandpaper, the experimental environment, tools and apparatus, that there were no impurities present, and the angle and positions of the photos taken. Next slide, please. Here you can see our experimental setup. We used pyrite, all the tools necessary in order to do the analysis and keep all the parameters constant, as well as sandpaper of the type of aluminum oxide in a grid size of 180. Here you can see the results of our first experiment. Here is a photo. It isn't really well presented in the projector, but you can see the streaks of the mineral here. And here is the streak color in the sandpaper. We can see that it falls under the black category. Here we have a comparison when it comes to the hue, saturation, and the lightness of the colors. So we can greatly and clearly distinguish that those colors are two different colors when it comes to the comparison. For our second experiment, our independent variable was the mineral category, which was in the family of sulfides. Our dependent variable was the color of the streak, and our controlled once again stayed the same. Next slide. Here you can see our experimental setup. For the types of minerals, as I mentioned before in the introduction as well, in the family of sulfides, we used chalcopyrite, sphalerite, galena. Again, the same tools and apparatus in order to keep everything controlled, and the same type and grade of sandpaper. Here you can see pictures of our results. And moving on to the analysis, here you can see a table showing that the streak color of all of the three minerals fell under the black category, while there is a significant difference when it comes to the mineral surface color itself. But let's look at that a bit more analytically. First of all, in galena, we can see the very big and distinct color difference when it comes to hues, saturation, and lightness as well. And moving on to chalcopyrite, there's once again a very big difference in hues, saturation, and lightness. And the same goes for sphalerite. There is a very big difference in hue. So we can clearly distinguish that all of the three colors, when compared to the streak and the surface color, were indeed different colors. For our third experiment, the minerals that we decided to evaluate our silicates, more specifically quartz minerals. The dependent was the color of the stick. Control, once again, were the same. Moving on to our experimental setup. We used the minerals agate, jasper, and citrine, which are all types of quartz. Once again, the only difference in the tools, this time we used a tool for color comparison. And moving on to our results, here you can see a picture of a result. Moving on to the analysis of the colors, we can see, these are the colors that we can see of the streak and the mineral surface color itself. But let's analyze that a bit more thoroughly. Here we can see that citrine, the comparison, the tool that we used, told us that that had a 90.65% similarity, while jasper had an 81.98% similarity, and agate had a 72.83% similarity. So we can see that the colors are indeed similar to their outside color. Now, moving on, all of our three hypotheses were indeed confirmed, but at this point, it is important to mention some possible errors that may have been evident. First of all, the reliability of the stored information, even though we did inquire even if it had undergone any purification methods. Some instruments failed. For example, our thermometer had a 0.5% inaccuracy, and the reliability of online current analysis tools, even though we did research to find the most reliable tools, there is always that possible error. These are our references. Thank you so much for your attention.
Thank you. Thank you very much for this report. Now it is time for the opponent to have the possibility to ask some clarifying questions. 3 minutes starting now.
Okay. So, hello, great presentation. I'd like to ask you a few questions. So, first of all, you said you used sandpaper to...
Yes.
Okay. I couldn't notice because of the presentation. What color was the sandpaper?
The sandpaper was, as you can see here, the color was toward...
It's black. Is it black? I can see.
It's black, red. Black, red.
Okay, thank you. Also, you said you picked 5 points. Did you pick 5 points at random? Did you pick?
Yes, the 5 points were random. There are 5 points of each of the streaks, so I think we think that that's a sufficient.
How many times did you conduct each experiment? 5 times as
yes, 5 times.
Okay.
I think it's mentioned in the experimental procedure.
Did you use the same rock each time?
We used the same rock, but not the same side of the rock. So it was a different side because the same side would have already been stricken, so the inside would have already been.
Thank you. What did you do about the lighting conditions? Were they constant?
Yes, as we mentioned, they were in the constants. We also used a luximeter. If you could go to the appendix as well, we have the lux of the room. In order to keep that stable, of course, we had all the blinds closed. There was one light source. Here you can see we measured the lux of the room, so it can be a constant parameter each time.
Okay, okay. Also, did I notice correctly that you didn't specify errors for the color measurements?
We did specify that in our possible possible errors when it comes to
Yes,
the
but
reliability.
did you say plus or minus 5% or that the color?
How can you calculate the color in a percentage?
I'm asking you. Did you do that? I'm asking.
I don't think that's you can calculate the color in a percentage. I would be more than happy to discuss that in the discussion.
Okay. Yes. Also. What camera did you use for the?
We used the phone. As we mentioned in our control, the angle was the same. We used the tripod in order to control that. If you could go to any control parameters here, angle and position of photos taken, it was always controlled so as to mitigate any possible errors when it came to that.
Okay. Also, so you said you used the same rock for the same piece of mineral for all the trials.
Yes.
Were those did all the minerals come from the same location, from the same mine?
Yeah, they were purchased from the same place.
No, where were they mined? Where did you get them from?
We are not aware of that, but we don't think that plays a role since we did take into consideration that they would be purified, they wouldn't have any impurities. So I don't think there's any other parameters of where they were mined that could have influenced the experiment and the results.
Okay. Also, did you consider the aspect of humidity?
We did consider the temperature, and humidity can actually only affect the results by affecting the temperature. So by keeping the temperature stable, we were actually able to. So you don't think?
Okay, so you think it doesn't affect the color?
Humidity cannot affect it directly. Can affect the temperature, which in turn can affect the experiment, which we kept stable.
Okay. Thank you. I think that's about it.
Thank you very much. Now it's 3 minutes for the preparation of the opponent. Please keep it quiet in this area. Quiet, please. 3 minutes starting now. Quiet, please. Quiet. Quiet, please. If you're ready to start, let me know.
I'm ready.
Okay, we are starting. This is the statement of the opponent.
Okay. So, hello, my name is...
4 minutes, starting now.
Hello, my name is Prometheus Nikou. I will be presenting my position to Team Gravities. So, the problem statement is if a line is drawn on the rough surface with a piece of iron sulfide, the line has different color than the mineral. Investigate this phenomenon and explain what other minerals show a similar effect. So first of all, the introduction of the phenomenon was pretty good. They did explain streak color and mineral color well. The theory was pretty good, although it needed some improvement and some parts could have been improved. The hypothesis and the experiments and the data analysis had some problems because of the way they sampled colors and the way the experiments were conducted. But the conclusions, I think the conclusions were mostly correct. And I think mostly the problem was in the experimental part. So first of all, for the theoretical part, the explanation of the theory was pretty thorough. They explained the difference between surface color and streak color and explained why it exists. The structure of the presentation was pretty good. And they also provided pretty good definition of the phenomenon of why this was happening. But they also had some bits of irrelevant repeating theory. Like, for example, what a mineral is, that wasn't quite so important to focus so much on. They had some unnecessary information. They didn't mention the significance of humidity and how it can affect the color of minerals. And they also, that's actually a problem with the experimental part, that they used dark sandpaper that might affect the color of the minerals, that might affect the color of the streak. Now for the experimental part, they had they had a pretty testable hypothesis, and they had good control of the variables. For example, lighting conditions, and they explained the procedure well, and they were very well conducted with enough trials, but they didn't show any video of the procedure, and they didn't have any error bars or graphs, so the analysis was, in the end, mostly qualitative, because they didn't have any graphs, and they didn't know where they sourced the minerals from. They didn't know where they were mined, and they also some specific points instead of taking all of the points and taking an average color. So what they could have done was have the second hypothesis be more concise and specific because it was a bit general, have more accurate measurements of the color during the experiments, and also better control variables like humidity and the minerals. And they also could have included more visual aid, like videos of the experiments. Even though they included photos, they could have included videos. And the most important part is they could have included graphs, because it would have been much more helpful to have a graph of the colors and instead of having just two color samples, because that's mostly quantitative analysis. Yes. Okay. That's it.
Thank you. Now it's time for the discussion. We have 5 minutes. So let's have the reporter to the stage. And are you ready to start?
Yeah.
5 minutes starting now.
Thank you so much for your presentation. I was actually wondering about a point that you made about graphs. What kind of graphs would you have suggested I use? Because the data that we got was quantitative, was not. Yes. It was qualitative, not quantitative. No, how could that be qualitative in
yes, good
graphs?
question. Actually, you can do quantitative analysis of colors using. You can represent their hue and their darkness.
Yes, but their hue is not something that you can compare using a graph. It is not a number. If it goes a bit up, it is a different color completely. You can't see patterns or anything else when using a graph.
Yes, you can about darkness, because in your
but a darkness does not necessarily differentiate the...
Yes, but in your experiment it does, because in your second experiment, I think, where you tested all the sulfides, all the colors were darker, so you could have compared the darkness and see that
I think there's been a misunderstanding. We're not
comparing... Actually, can I ask you a question first?
Can I please finish my thought?
Yes.
We are not comparing whether one color is darker or lighter. We're
comparing the colors.
We're comparing whether the colors are different. And I actually wanted to go, if you could go to
yes, if I can ask you a question.
Yes, of course. And
so you said that the sandpaper, if you can go to the sandpaper, it was dark. So I saw in your results that most of them were dark. So don't you think that the dark sandpaper could have affected the color? Why did you not use a white sandpaper, for example?
First of all, I'm not aware if something like that even exists, but we do not think that that affects the color, because even if it was a bit darker, it would still be the essence, it would be the same color, it would have the same hue. However, because it is a different color itself, this is more of the black category, yellow, this is blue, and this is purple. It's a different color itself, it's not the hue that plays a sense.
Yes, but it's mostly dark.
Yes,
I think it might be dark because the sandpaper was dark.
But we also
maybe if there was a white sandpaper, maybe the colors would be lighter, and you could actually see that they were.
I'm not saying that they would not be lighter, but they would not be the same colors. It's what the theory suggests as well, that the colors would be different. I wanted to make a point about the temperature and the humidity.
I have one more question to ask you.
Can I say about the humidity, because I think it's an important parameter.
I want to ask a question first.
Okay.
You said that you used only one rock, and you scratched different sides of it.
Yes.
Do you think it would have made any difference if you took like 5 different rocks and scratched each one?
The essence of the experiment would remain the same. This is what the theory suggests as well. The minerals that fall under the sulfide category would have a different color, and the minerals that fall under the silicate would have the same color. And we also, as you can see here, we did also repeat the experiment using different types of minerals that fall under the category, so that was not a problem.
Okay.
I wanted to stress something that you said about the humidity. I'm very curious as to why you think that could have affected the results. If you could go to the appendix about the temperature, please, because we actually believe that the temperature, as you can see here, there is a variety of ways that the temperature can affect anything, of course. However, thermal expansion, phase transition, as well as chemical reactions are things that affect the mineral's hardness. The mineral's hardness does not play a role when it comes to the color. It plays a role into how pronounced the color is. Only the annealing can change chemical properties, but that can only happen when the temperatures are in extremes. Can I please finish my thought? Only when temperatures are in the extremes. So that does not actually play a role when there's such small deviation.
You said why humidity matters. Well, we know for a fact that many minerals, when they're anhydrous, they have a different color than when they're hydrated.
Yes, so but that is only in extreme changes of temperature and humidity.
Yes, but you didn't specify humidity at all, so that's a problem. Maybe humidity could have been a problem. That's what I was saying. You didn't specify humidity at all.
Humidity only affects when it affects temperature, because temperature is what can affect what you mentioned before. And because we kept the temperature stable, and because what you said only happens in extreme changes of either humidity or temperature, it wouldn't play a role at all.
One more question. Do you think it would have made any difference if you took your rocks from a different mine, if you sourced them from a different location?
As I mentioned before, as it comes to first different nodes and different mines, since we did guarantee, we mentioned that in our control variables as well, that there were no impurities present, they would not make a difference because they would be the same rock.
That's not what I'm asking. That's not what I'm asking.
Yes, but that's what I'm asking
you. No, that's not. I'm asking you if you talk.
It would not make a difference. That's my answer.
Okay. Also,
because it would be the same rock, and the theory suggests as well that the results are valid, so I do not believe that
also,
that is.
You said that you took photographs and you used the lux meter. Don't you think you could have used the spectrogram instead to measure for the colors?
What, can you explain what that does?
It separates the light into the different wavelengths. You can see the different colors, the individual colors.
That might have been a bit more inaccurate, because we wanted to see the exact color, which can be done.
Finish your statement.
Which can be seen, as we saw, with hex analysis and RGB analysis.
Thank you very much. Thank you for this discussion. Now we can have clarifying questions from the reviewer to the reporter, and reviewer and reporter, opponent and reporter, stay on stage, please. Let's have the reviewer. 2 minutes starting now.
Thank you for the discussion. Question for the reporter. Do you think the pressure applied in the streak plates could have affected the results?
Actually, no, and we have conducted an experiment for that as well. You can see that it affects only how pronounced the mineral color is and not the mineral color itself.
Thank you. Question for the opponent. What improvements would you like to see in the theory part?
In the theory part, actually, I would like for the reporter to spend less time explaining what a mineral is, because that information was not so useful.
Yes, but what improvements would you like to see?
I just told you.
Would you add something?
Mostly remove and change the time spent. And
okay, thank you. A question for the reporter. How did you calculate the average color?
The average color, we take color, we take pixel colors and then we blend them all together, and this is the average color.
Okay, another question. Why didn't you use other streak plates for your experiments?
Okay, so thank you. If you could go to the appendix, we have a slide on that as well. We chose sandpaper in order to have a controlled roughness, and it is in the appendix, please. In order to have a controlled roughness, and because as we controlled it further before.
Okay, thank you.
Surface also doesn't play a role in how pronounced the color is.
Thank you.
Only,
question for the opponent. Can you elaborate why the hypotheses were weak? And why the hypotheses were weak?
Well, that's not exactly what I said, but I said that they were very abstract, they weren't very specific. And also that the last hypothesis was not related to the problem statement.
Okay,
so
thank you.
More
question for the reporter. Yes. Can you explain what impurities in minerals are?
Yes, impurities are when other chemicals are evident apart from the chemical composition, and that can have an impact in the chemical composition if other minerals are present. But this is why we made sure that they would undergo purification techniques, which are techniques that remove those extra chemical elements if they're evident.
How were you sure about that?
We inquired about the story, and we also included in the parsable layers that they might have been an unreliability on that.
Thank you very much. Now you can go back to your places, and we have 2 minutes. 2 minutes for the preparation of the reviewer. Quiet, please. Timer starting now. Quiet, please. Quiet. Quiet, please. Quiet, please. Quiet, quiet, please. Silence in the room. Shh.
Έχει κανένα HDMI υπολογιστή.
It's time to hear the statement of the reviewer. You have 3 minutes, starting now. Statement of the reviewer.
Το βάλες.
No, the timer starts when I say so, but you have to be ready. Are you ready? Because we're starting. Timer is continuing. Quiet in the room, please.
Hello everyone, my name is Hans Papa.
What is it? Hold the timer, please.
We can't. Δεν έχουμε αντάπερα. Ένα λεπτάκι.
What is the technical issue there? Let's have the jury vote. Do we reset the timer or do we continue with the timer?
No, please wait. It's on me.
It's on you. Okay.
Since this is the final fight and we are live and we have always technical difficulties, I believe that we must see the best from each team if we do not have this problem affecting.
You're suggesting that we reset the timer?
I suggest that we don't start if they are not ready to start, but of course keep it guys on time.
Okay, thank you.
Let's get the timer back. Resetting the timer, reviewer takes the stage. You have 3 minutes starting now.
Hello, my name is Tamis Papadimitriou and I'm the reviewer for Team Shockwave. Let's start with the reporter. About the pros, the report had sufficient theory. The theory was fairly detailed. It included diagrams and pictures in the results and answered all of the opponent's questions with ease. About the cons, though, did not take into account the friction surface of the minerals, something that could have altered the pressure, and we believe that it plays a big role in the experiments. Furthermore, the color of the streak plate was not considered as a possible error, also a very big flaw in our opinion. Furthermore, only one streak plate was used. Let's move for the opponent. About the pros, presented good clarifying questions. They explained their points on the general outline of the presentation slide, something that few teams do, and gave good suggestions for further improvement. About the cons, put the cons of the experimental procedure in the theory part, missed many flaws that we will explain later, and he made some points in the discussion that weren't relevant to the problem in our opinion, and I think he was not dominant enough in the discussion. About the points discussed, first point, the opponent argued that the origin of the minerals can affect the experimental results. The reporter said that they believe that this didn't play a major role, and our opinion is that we agree with the opponent. For point number 2, the opponent stated that the temperature was not controlled, and that it could have been critically affected the experiment. The reporter denied the effect that temperature can have on the results, and we agree with the reporter because the experiments were conducted in a lab. Point number 3, about the second experiment, the opponent argued about the brightness of colors. The reporter answered that they tested the differences between the colors and not the brightness, and we agree with the opponent in this point. For the last point, the reporter asked the opponent how is the humidity capable of altering the experiment. The opponent answered that when the minerals are hydrated, they have more vibrant colors, and our opinion is that we agree with the reporter once again. About the points missed, though, there was a lack of error bars, lack of streak plates, as only one streak plate was used, the black sandpaper, and then there was no mention of friction in correlation to the pressure applied in the streak tests. For the conclusions, the presentation of the reporter was average, as well as the response to the critiques. The understanding to the problem and the response to clarifying questions were great, in our opinion. About the opponent's statement and clarifying questions were great, but the critiques to the reporter and discussion presence were average, as he wasn't dominant. About the suggestion for further improvement, the reporter tried to further investigate the experimenting with more streak plates, and tried to investigate more families, types of mineral. And for the opponent, tried to point out more flaws in the experiment, such as the friction surface, and tried to be more dominant in the discussion. Thank you very much.
Thank you. Thank you very much. Concluding remarks from the opponent, 1 minute. The opponent.
Okay.
1 minute starting now.
First of all, I'd like to say a few things about the review. First of all, I did mention error bars in my presentation. And also, in the discussion, I asked about humidity, I think, not temperature. So, yeah, that's one thing. Also, I think that the discussion would have been much better if the reporter was not so aggressive and so dominant, because I couldn't ask questions they weren't answering. Also, for the report, I think it was mostly good, but it could have been improved by controlling the source of the minerals or considering different sources for the minerals. And also, the experiment would have been better if there was a quantitative analysis of the results by using a spectrogram, or at least sampling all the points, not 5 random, all the points in the area of the streak. Other than that, I think it was a good fight. Thank you.
Thank you for these remarks. Finally, concluding remarks from the reporter. Are you ready? 1 minute starting now.
Thank you, everyone, for this science fight, and sorry if I came up aggressive. I just wanted to get my points across. However, I do want to point out that I failed to understand how error bars and graphs could have included in this presentation. Also, pressure and friction, which were mentioned by the reviewer, do not play a role in the mineral color, but rather how pronounced it is, which was something that we did not experiment with. Thus, we did not find necessary to include that in our presentation. The temperature was indeed controlled, but it didn't play a role. And also, we want to point out that we did conduct more experiments with other types of sandpapers, not strict plates, but sandpapers, which we did include in our appendix, but because we were not questioned by the opponents in any points regarding that, we did not have a chance to present that. Otherwise, thank you for all the points. They will be taken into consideration, and thank you both to the opponent and the reviewer for this amazing science fight.
Thank you very much. Questions from the jury? Clarifying questions from the jury. Anyone? Yes, please. Sure, go ahead.
Sorry, maybe it wasn't very clear for me, but how did you estimate the exact color?
Yes, so we used the color picker tool. We used the color picker tool. And we used 5 different, and we blended them all together, which was the average. And then using that, we estimated the color and the hues and the lightness and the saturation, which in turn shows us what color it is.
Okay. Other clarifying questions? Yeah? No? Go ahead. No. Any other questions? I have to assume that there are no further questions from the jury. Let's get to the grading. All sheets have been filled and signed, and then the jury is ready to show the grades for the team of the reporter. I will read them twice as asked by the technical assistant, so hold the grades up for a little longer while I read them 2 times. Starting from the right to the left, we have 21, 24, 23, 24, 25, 23, 23, and 21. Once again, hold them up. Right to the left, 21, 24, 23, 24, 25, 23, 23, and 21. Thank you very much. This concludes our fight, and now probably Apostolos has something to say, organizational. Here's the microphone.
I have nothing to say. You handle it very well. So, stage 2 is over. What? To say something about the grades? What? Sorry, I'm out of... Say that again. So you wanted to humiliate me online?
No, not at all. We are taking a little break and we're starting the third part.
Okay, let me explain to the parents what's happening. Είμαστε αυτή τη στιγμή στο δεύτερο stage. Σωστά τα λέω, παιδιά? Ποιος παρουσίασε τώρα? Η Gravity's Cube και όχι Square που είπα πριν. Πέρασε η χρονιά. Λοιπόν, νομίζω την είδατε τώρα τη διαδικασία. Είναι λίγο κουραστική διαδικασία διότι οι αγώνες παίρνουν πολλή ώρα. Παρ' όλα αυτά, εδώ βλέπω έτσι μεγάλο ενδιαφέρον από όλους να παρακολουθήσουν. Και θα το ολοκληρώσουμε και θα περάσουμε και στο τρίτο stage. Και αμέσως μετά θα ακολουθήσει στα ελληνικά τελετή λήξης και βράβευσης όλων των ομάδων. Ευχαριστώ.
The team of the opponent. Let's have them. Are you ready? Which is ready? For the team of the opponent, let's have them up. Right to the left, I'm reading 13, 14, 13, 14, I have 16, 15, 15, and 15. Let's have them for the second time. Right to the left, 13, 14, 13, 14, 16, 15, 15, and 15. Thank you very much. And now the grades for the team of the reviewer from the right to the left, starting now. 7, 8, 8, 7, 7, 6, 7, and 6. Once again, from the right. 7, 8, 8, 7, 7, 6, 7, and 6. Thank you. And now it's the time for the break. Let's don't scatter too much.
Okay, thank you. 5 minutes break.
5 minutes break.